All right, before I try to define what an isotope is, I think it's probably better if I start with an image. So I went out and I found this image, and this image shows three different, let me say nucleuses. Actually, the best way to say it is nuclei, but this is three different nuclei of carbon. So if you look at this, what you're supposed to notice is that every one of these nuclei, if you count up the protons in purple here, you're going to wind up with 6 of them. So as you run through, just double check that you wind up with 6 pluses in each one. So that shows us right off the bat that every one of these nuclei is carbon because they all have 6 protons. Okay, but what's different among these? Look at the neutrons. They put these in red here. So I've got 1, 2, 3, 4, 5, 6. So I've got 6 neutrons. And then 1, 2, 3, 4, 5, 6, 7. So I've got 7 neutrons. And I've got 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8 neutrons. So if I count these up, if I want to know the mass of the elements, 6 and 6, so this one is going to be 12. 6 and 7, that's going to be 13. 6 and 8, that's going to be 14. So what sets these apart? How are they all different from each other? Well, it's the mass number. So if the mass number is different, but the proton number is the same, what does that mean? That means that who really matters here, as far as isotopes go, is the neutrons. So maybe we're ready to make a definition for an isotope. An isotope is a different mass atom. It's like a 3-word definition. So a different mass atom. So take a look at these again. This one right here, this one is carbon because it's got 6 protons. This one is carbon because it's got 6 protons. This one is carbon because it's got 6 protons. But they're all different because they have different number of neutrons. In other words, their mass is different. All right, so that's my definition of neutron. Maybe you can go out and find a better one, but I'm going to stick with that one for now. So I've been in classes before where professors are talking about different isotopes of carbon, and they often use the word forms. So this form of carbon has a mass of 12. This form of carbon has a mass of 13, and so on. So the definition or a synonym for the word isotope could be form or forms, and maybe you'll hear someone say a different weight or a different mass of carbon. So synonyms for isotopes are different. The best one is probably forms, but they have different weights. They have different atomic masses. All right. So the atomic symbols then, the atomic symbols are different. How are they different? They are different in the number, the mass number. The proton number, however, stays the same. They all have 6, but you knew that already, okay? So let's tie this in with the periodic table just for a minute here. I just got this offline. So right here is a symbol for carbon, and we know that the atomic number is 6. We've already said that everybody here has 6 protons. We knew that. And then look at this number, the mass number. This is 12, and I see a 12 right here, but this is 12 point something. It's 12.0107. So what can I guess from that? What do I know? If I went out around the whole planet and I started scooping up carbon atoms, I just started looking for carbon, what would I find? I would find that most of the carbon has a mass of 12. So if I had to guess, I would say that most of the carbon atoms on the planet are like this one. But I would know that there's some of these and some of these. There must be a few because the average mass is a little bit above 12. So when you look on the periodic table at different mass numbers, you need to know that the number up here, the mass, is an average. So unless you see an exact number like 12.0, which is pretty rare, you know that there are different isotopes, there are different forms or different weights of atoms out there that have different numbers of neutrons in their nucleus. So why do scientists talk about different isotopes? Well, maybe you've heard of nuclear power. nuclear power plants make electricity for us, and people talk about that. So how do we make nuclear power? Well, we use different forms of uranium. We use different isotopes of uranium. There's uranium-238 and there's uranium-235. These are both different isotopes. So that's one reason to know about isotopes. Another reason to know about isotopes is maybe you're talking about stars, like our sun. How does our sun work? Well, our sun works based on hooking hydrogen atoms together to make helium atoms, and that's what gives us all of our sunlight. So if you look here, here's one proton. That's called deuterium. We don't really care about that. This one's got a proton, but it's got two neutrons, but it's still hydrogen, so that's called tritium. So these, what are these both? These are both isotopes of hydrogen. So when you take this one and put them together, what you wind up with is helium. So our sun is actually making helium. So if you're worried about nuclear power, or if you're worried about solar power, those are both good reasons to learn about isotopes.